Even when you feel low, you can still go. Even when you feel slow, you can still go. Even when there's no hope, you can still go. I never answer to no, man, I still go. Go, 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 go.
Fundamentals of mass balances, energy balances, and material flows. Mass balance, or material balance, is a fundamental concept in chemical and industrial engineering, where the total mass entering a system is equal to the total mass leaving the system, plus or minus any accumulation within the system. It ensures material conservation within processes, which is essential for process efficiency, safety, and regulatory compliance. It also helps in optimizing resource usage and minimizing waste generation. In a chemical reactor, mass balance can help track the amount of raw material entering the reactor, the amount of product formed, and any waste generated, ensuring no material is unaccounted for. This is the equation for mass balance. It basically says that the total mass of input must be equal to output plus any accumulation, or total input of mass or energy minus the total mass or energy of output equals to accumulation of a product. This is used in steady-state and non-steady-state systems. However, in steady-state conditions, accumulation is zero, simplifying the equation to input equals to output. What's the applications of this? Number 1, chemical reactors. It is used to determine the amount of reactants consumed and products formed. It is also used in distillation columns to track the separation of different components in a mixture. Also in water treatment plants. It is used to balance the inflow and outflow of water and chemicals used in treatment. And energy balance is the accounting of all energy entering and leaving a system, along with any energy accumulated within the system. It follows the first law of thermodynamics, which states that energy cannot be created or destroyed, only transformed. The importance question mark. It can be used for optimizing energy usage by identifying energy losses and areas for improvement in industrial processes. It is also used for environmental compliance by monitoring and reducing energy consumption to comply with regulations. In cost control, the lower energy consumption leads to cost savings and improved profit margins. For example, in a furnace, energy balances ensure that the heat entering the system from fuel combustion is sufficient to reach the desired temperature for the product with minimal energy loss. Similar with mass balance, energy balance has exact same concept, except that this time energy is the accumulated product, or energy is stored in the product. This is the first law of thermodynamics, that energy cannot be created nor destroyed, only transformed. In chemical plants, units such as boilers, heat exchangers, and power units obey this law and ensure cost and energy efficiency. Another important concept you need to know is the material flow. The flow of materials refers to the movement of raw materials, intermediates, and finished products through an industrial system. Key components tracked include raw materials, intermediates, products, and waste, e.g. emissions, byproducts. This ensures the proper utilization of raw materials and tracking of product yields. It helps in identifying inefficiencies, bottlenecks, and areas for waste reduction. Therefore, critical for cost estimation, as accurate flow data is needed to calculate the total costs of production and waste management.